This is a review for your logarithms test. On number 1, you have log base 7 of x is equal to 3, and you want to just change this to exponential form. So to change to exponential form, you take the base of your log, and it becomes the base of this number over here. So you have x equals 7 cubed. You don't have to solve it, you're just changing it into that form. Log base 3 of 81 equals 4. So again, 3 goes over there, so you have 81 is equal to 3 to the 4th. Find the exact value of log base of 9 of 243. So you can use your change of base and choose a base that both of these numbers go into so that they could have for this. So that would be 3. Log base 3 of 243 divided by log base 3 of 9. 3 to what power is 243? Well, that's 5. 3 squared is 9, so my answer is 5 over 2. You could also do your change of base in the calculator. Log of 243, close your parentheses, divided by log of 9. And that gives you 2.5. B, log base 2 of 16. Well, 2 to what power is 16? That is 2 to the 4th, so that is a 4. Your answer there is just 4. Solve the following for x. Alright, so here we have log base 9 of 24 plus log base 9 of 1/2 equals log base 9 of x. Because we are adding the two separate logs, we'd multiply their inside. So log base 9 of 24 times 1/2 equals log base 9 of x. Half of 24 is 12, so I have log base 9 of 12 equals log base 9 of x. So x is 12. Log base 6 of 1 over 36 equals x. So 6 to what power is 1 over 36? Well, it's a reciprocal, so I know it's a negative, so x is equal to negative. And to get 36 from 6, I'd square it, so that's a negative 2. Log base 2 of a is equal to x. Log base 2 of b is equal to y. Find the following in terms of x and or y. So we're going to expand these. So expanding means to write them as long as possible. So this 2 goes out in front of my log with b. So I'm going to have 2 log base 2 of b. I'm dividing, so then I'm going to subtract log base 2 of a. Well, I know that log base 2 of b is y, so I have 2y minus, and I know log base 2 of a is x, so 2y minus x. Log base 2 of a cubed plus b, or sorry, times b. So the cube comes out in front, so I have 3 log base 2 of a plus, because these are multiplied, my b does not have an exponent to come out in front, so it's just log base 2 of b. Replace this with x, so 3x. Replace this with y, so plus y. Log base 2 of the square root of a. Well, the square root is the same as the 1/2 power, so that'd be 1/2 log base 2 of a. Log base 2 of a is x, so that's 1/2 x. Write log base 2 of x minus 3 plus log base 2 of x plus 3 is a single logarithmic expression. So log base 2 of, because I'm adding the two separate logs, I'm going to multiply their inside. So x minus 3 times x plus 3. That's all you have to do. You can simplify this further and say log base 2 of x times x is x squared. That's 3x. Negative 3x cancels. Negative 3 times 3 is a negative 9. Either of those works for this question. Then I want to solve for this when it equals 1. So log base 2 of x squared minus 9 equals 1. I'm going to change this to an exponential, so x squared minus 9 is equal to 2 to the first, which is just 2. X squared is minus 9 equals 2. Add 9 to both sides. X squared is equal to 11. So x could be equal to, if I took the square root, positive or negative square root of 11. Square root of 11, if I have it as a negative and I plug it in, I'm going to be taking the log of a negative number, which I can't do because that's extraneous. So the negative is extraneous. because that's not in the domain. So my answer here is just the positive square root of 11. Change to logarithmic form. So these are similar to the ones you saw on the first page. You're just changing them from exponential to log. So this is going to come over to this side and be the base of my log. So I'm going to have 7 minus x equals log base 3 of 21. Same thing on this one. My x is going to come over here and be the base. So I have 7 equals log base x of 128. Solve the equation log base 2 of 8 plus log base 2 of a half plus log base 2 of 11 equals log base 2 of x. So again, I have pluses in between, so I'm multiplying their inside. So log base 2 of 8 times a half times 11 is equal to log base 2 of x. Half of 8 is 4. 4 times 11 is 44. So log base 2 of 44 equals log base 2 of x. So x is 44. 25 to the 2x minus 3 is equal to 5 to the 7x plus 12. So I need a common base. My common base here is going to be 5 because 5 to the first is 5. 5 squared is 25. So 5 squared to the 2x minus 3 equals 5 to the 7x plus 12. Now that I have the same base, I can set my exponents equal. So 2 times 2x minus 3 equals 7x plus 12. That gives me, when I distribute 4x minus 6 equals 7x plus 12. Subtract 4x from both sides. Subtract 12 from both sides. I get negative 18 is equal to 3x. Divide by 3. X is negative 6. Solve the following logarithms. Log base 3 of 81. Well, 3 to what power is 81? That is 4. 3 to what power is 1? Any number to the 0 power is 1. And the natural log of e squared. Well, natural log and e are inverses. Those undo each other, so it's just my exponent there, 2. Given log base 2 of x minus 1, and I have two different functions right here. F of x is equal to log base 3 of x plus 7. We're going to work with the second one. Okay, so I apologize. We are going to work with the one I just marked out. We're going to work with the first one. Log base 2 of x minus 1. So if I plug a 4 in, so f of 4 is equal to log base 2 of 4 minus 1. Well, 2 to the, what power is 4? Well, that's 2 to the second power, so 2 minus 1 is 1. That proves that. Find C if f of c equals 3. So log base 2 of c minus 1 equals 3. I'd add 1 to both sides. Log base 2 of c is equal to 4. Change this to an exponential here because this variable is inside the log. So I'm going to have c is equal to 2 to the 4th. 2 to the 4th is 16. So c is 16. The domain. So the domain of our logarithm is going to be from negative infinity to from 0 to infinity. My range is negative infinity to infinity. Find any asymptotes. This is going to have an asymptote at y equals 0. An x-intercept. So an x-intercept occurs when the y value is 0. So when this is equal to 0. So 0 log base 2 of x minus 1. Add 1. I get 1 is equal to log base 2 of x. Change it to an exponential. X is equal to 2 to the first, which is just 2. So it has an x-intercept at 2, 0. I know I have a point at 4, 1. I know I have a point at 16, 3, which is off my graph. 6, 7, 8, 9, 10, 11, 12, 13, 14. It's right in there somewhere. My asymptote is right here because it hasn't moved left or right because I don't have anything I'm adding or subtracting from x. if I wanted to find this point, I can think of what's another easy number to take the log base 2 of. Well, that'd be 8. Log base 2 of 8 is 3. 3 minus 1 is 2. So I'd also have the point of 8, 2. Sketch my graph. Find the inverse. So inverse is when I switch my x and y and solve for my new y. So x equals log base 2 of y minus 1. First I'd add 1, so I get x plus 1 is equal to log base 2 of y. Then I'm going to change this to an exponential, so I'm going to have 2 to the x plus 1 equals y. Then I'm going to replace my y with my inverse symbol. So the inverse function is 2 to the x plus 1.